It's not just a third world issue, it's definitely a first world issue. Most governments that have access to coastlines are embarking on ambitious desalination programs. With receding glaciers and falling water tables, we know that fresh water is going to be a big issue as we face in the coming years ahead. Now, space-based solar power can help here because most people involved in desal understand that the biggest desalination, it sucks enormous amounts of energy. It requires huge amounts of energy. Disaster relief. We have the ability today to put relief workers on the ground in a matter of hours almost anywhere in the world, whether it's hurricanes, tsunamis, earthquakes like last week in Indonesia. The challenge is not getting people there, the challenge is having power ready for them to be able to use their tools, where most of the infrastructure is usually knocked out. And I'm not even talking about some of the economic benefits of space-based solar power, including 250,000 jobs that is likely to be generated in the US alone at a time where unemployment is the highest for nearly a quarter of a century. The tens of thousands of jobs in the countries that can actually embrace and take the energy contracts for these satellites, and we're talking to several. The economic implications I could talk about for another hour. But let's talk about, let's address one concern, which we heard on the last video as well. Number one concern usually is safety. Well, we have a 50-year history now of being able to send up satellites powered by rockets into orbit that are powered by solar panels that generate that electricity, convert it into a radio wave and beam it back to Earth. It's called the communication satellite industry. And as a result of that, the last 50 years, everybody in this room today currently has the equivalent of the Library of Congress being broadcast through them every second. You'll be pleased to know that the physics of wireless power transmission are very well understood, they're well documented, especially by our team who understand all of the intricacies involved. It is safe, it is reliable. The beam transmission from the satellite to Earth is safe for humans, animals, and plants. In fact, the strongest part of the beam, the energy density, is weaker than natural sunlight. It comes down to a receiving antenna, which is like a large mesh wire grid on the floor. It's a simple technology, and it's uninhabited. You compare that to a nuclear reactor on the ground or a dust-spewing coal plant, and I know which one I'd rather choose. Another factor to take into account, and the question we get asked is, can this be weaponized? Categorically, absolutely not. You couldn't weaponize a space-based solar power satellite any more than you could a satellite broadcasting CNN or Sirius radio. In fact, the reason the Pentagon did their study over the open internet for the first time ever was to assure people they were looking at ways to avert war, not trying to hide some clandestine new weapons program. So, if we understand that it's safe, we understand the technology is available, we understand it holds enormous promise for many different aspects of society as we move forward, then the only thing that was stopping it was the business case. So let's take a quick look at that for a second. Well, our calculations put the cost of the first 1 gigawatt satellite somewhere around $16 billion. Now that may sound a lot. It's certainly not going to come from something like the space tourism market, which is still in its infancy. But we're not in that market. We're in the energy market. $2 trillion a year and growing every day. But if we just compare that to, for example, like a nuclear plant, I think you'll find the figures interesting. A nuclear plant today costs between $4 and $6 billion on the low end, up to $10 billion on the high end, depending on which technology you use and whereabouts in the Earth you decide to build it. That's for procurement and build-out, engineering. If we then add in maintenance, operations, transmission, and fuel costs over the life of that plant, you could add another $6 or $7 billion. If we then take into account the UK government audit statistics saying that their latest costings for the decommissioning of the current plants here in the UK are coming in at $6 billion each, we end up with a lifetime cost of a nuclear plant anywhere from $17 billion on the low end up to $23 billion on the high end. That makes space-based solar power competitive today. And the price of sunlight isn't going up, unlike the cost of oil and uranium. And that's before we deal with the nuclear waste issues. And also, history has shown that over time, the history and costings of electronic components come down. I know there's a lot of innovation in rocket technology and launch costs, which we hopefully will reap the benefit of over the next 5 to 10 years as well. Is it profitable? Well, it's not going to happen unless it is. And the fleet of satellites that we intend to build cumulatively over their lifetime can put down over $210 billion worth of energy. Kind of puts a $16 billion figure into perspective. So, well, that's what we think. What are the next steps? Well, we've spent the last 2 years and several $1 million building a world-class team and a solid foundation. Our next step is to launch a demonstrator into low Earth orbit to validate everything that we're speaking about here, and that'll cost about $300 million. Again, put that into perspective, it's the same price as the last Pirates of the Caribbean movie. Okay. From there, we expect to close power purchase contracts, and off the back of that, we'll finance our first gigawatt satellite, and that will take about a 5-year build-out, which incidentally is about the same time as a nuclear power plant or a coal plant on the ground today. So again, that's what we think. What do other people think? Well, this is former President of India, President Kalam, who was also in charge of their space program for a few years, understands space-based solar power and its implications, and a big fan. He said, what better vision can there be for the future of space exploration than participating in a global mission for the perennial supply of renewable energy from space? Sir Richard Branson, also involved in the space tourism industry right now, he says, I believe that someday we'll be able to use space as a source of energy for the planet through solar power satellites, using the most sustainable source available, our sun. George Friedman, a very respected futurist, just came out with this book, The Next 100 Years, on the New York Times and Amazon bestseller lists. He clearly states on the front cover of that he thinks that space-based solar power will be the energy of choice as we move forward into this century. And then earlier this year, the large utility firm PG&E, Pacific Gas and Electric, on the west coast of the US, approached the California government for permission to sign a 200 megawatt power purchase agreement for energy delivered by space-based solar power starting around 2016, which falls in line with our timeframes. And I'm pleased to say that last month, the Japanese Space Agency and government, along with industry partners like Mitsubishi, announced they were investing $21 billion to build out their space-based solar power program over the next 30 or so years, starting with a 1 gigawatt satellite. See, space-based solar power is real, and it is happening today, and it is set to change the world. With the enormous promise and potential that it has for this planet, it has to. You see, it's time that we started to accept and embrace and acknowledge that space-based solar power is not only a clean and viable source of energy for the world, it's not only an inevitable technology that is happening. It's not only a profitable business venture, but more importantly, it offers a global solution to some of the most serious challenges that we've been facing ever in modern history. And we are proud and excited to be a part of it. Thank you.